Okay, so hello folks. Uh, Welcome back to my next video. So in this video, I would like to uh, do the final demonstrations of our Hackster projects. Right. So as I explained in the previous videos, right, and the previous recordings, will uh, I would like to develop this kind of IoT system, right? Where we got our data from this soil sensor Modbus with what UART RS485 interface. We can get the Modbus data, and we need to transfer the data to our LoRaWAN gateway. And using this gateway, it managed to send the data to the cloud server. All right. So one thing that I want to notify here that actually this cloud server, right? How to say? It's not the actual cloud server. I will say my own internal uh, Ubuntu server. So since I my uh Amazon cloud service account is banned, so from the Amazon, right? So I could not access my account anymore. So uh, I need to find out another way by creating this cloud server, right? Creating the local server where I install my Ubuntu, right? And the things board, dashboard. All right, let's get started from the firmware that have been developed for this final demonstration, right? So basically, uh, in this final demo, I just combine, like the combine all of the codes that have been demonstrated in the test, right? For example, the LoRaWAN test, especially that I saw in the another recordings, right? And then Modbus query test, and then also uh, read and write files into SD card. So, but unfortunately, right, it seems that there is an issue with the firmware or the library uh, inside of Arduino, right? Somehow I cannot use the virtual SPI to perform uh, this write and read file. So, as you know, right, let me explain a bit. So in this LoRaWAN apps, right, to do the uh, LoRaWAN connectivity between the our ESP module and the RFM95, we need to use SPI communications, which is taking in the hardware SPI from ESP32, right? And then also, right, for this SD application implementation, it is used also the SPI interface, serial preparer interface, right? Somehow, actually, from the ESP uh, library, right? They are able to provide two kind of SPI. First is the hardware SPI, and the second is the uh, virtual SPI. What's so called the VSPI. Somehow, this VSPI is not working. I mean, it's not. actually working. It can read and write the file, but somehow it's override, right? They override the SPI that have been declared for was it the LoRaWAN or RFM 95. That's why when I run uh, RFM inits, right, and then I submit this job, right, this SD card inits that utilize the SPI, even though it's different SPI, but somehow the settings or I don't know the configuration is overridden by the this SD card. So even though it can write and read, somehow the RFM or the our LoRaWAN model will not uh, you know giving any response or initiate any communications to LoRaWAN gateway. So that's why I need to comment out, right, the any of SD card uh, functions here, right? So what the things that I uh, code here is just querying the Modbus. After we get the that data, right, data query, we need to convert to the temperature. Uh, this one and is it? Yeah, this electricity. It's not electricity, electric conductivity, right? So somehow we need to convert, and after we convert, we need to copy or store the data inside of the our LoRaWAN buffer. And our the LoRaWAN event or what we call the application here will taking in this LoRaWAN data automatically into the buffer and send it to the gateway. Right. So as you can see here, okay, let's see one by one, side by side, right? So this is our hardware right now. I'm using uh, my USB camera. I know it's not that uh, clear enough. I mean, yeah, this is the best USB camera for PC that I have. So even though it's not clear, but hopefully it's able to explain more about the project that we are going to have. So if you can see here, this is the soil sensor, right? And this is soil. I just put the soil here and burn half of the sensor to the soil and sorry, I mean yeah. So this one the power is connected to the USB and it's power up. So you see it's somehow the conversion UART to RS485 is blinking means that it is requesting the data. So from this firmware, right, I designed that this Modbus query data will be initiate every 20 or 30 seconds, right? But this uh, uplink data will be initiated every 60 seconds. So basically, we can uh, see from the code, right? So the the X interval is 60. So this is the scheduling that we have. So basically, it will upload our data every 1 minute, right? So yeah. And then so yeah, this is the firmware, right? I will explain in detail from the article that I'm going to write in the Hackster page. So this is the debug message that we have, right? Using the uh, what is it? Using the firmware that we have, right? So it's seems that yeah, it is successfully querying every 20 or 30 seconds with this value, right? And then yeah, this is where we got uplink message from our baseboard, right? Okay, let's see. We have new data incoming, new data, right? So okay, let's go back again. So basically, once we have our data sensor, right, we are going to send it to the data to the Valorant gateway. So how? So basically, we can see from the log itself, right? The debug message itself, right? This is they come from the Valorant activity, right? Uh, Text complete means that the uplink message is transferred successfully, right? Okay, so we can check from our gateway side. See, let's uh, go into our lower one server here. So yeah, uh, so if you see here, right, the latest data is you see 6:54 p.m. So I just received the data, right? So every data contains this. Honestly, this one is pretty long data that actually it's not, I would say, uh, it's not meant to be delivered by LoRaWAN because the LoRaWAN should be as should contains the as the data as small as possible. But for this demonstration, I just want to show, right, whether it can deliver the data or not. Right, so here the information like the information that contains the node, right, for example, and this is the frequency since I live in Southeast Asia, right? It is mandatory to follow the regulations, right? So and then you see here, yeah, the most important thing is this data, right? So basically, we successfully gaining the data from uh, if we trace back, right, regain the data from sensor and deliver it to the LoRaWAN gateway, right? All right, good, good. So the next thing, right? The next thing, if we go back again, right? The next thing, once the data is delivered to the LoRaWAN gateway, how are we going to see the data into the things board, right? The things board dashboard or our call server. So as I mentioned uh, in the early of this recordings, right? I don't have cloud, the actual cloud server. I mean, like the Amazon things, right? So I need to install my things board in the local server that means that in my local PC, right? So let's see. Seems that there is a few seconds delay, right, between the LoRaWAN uh, and then the things board, right? The few seconds delay. This is the latest data that I received, right? 29, 60, 62. Let's see if we have. The same data is, where is it? 2962, right? This is the latest one. I don't know how to see the history, but yeah, this is the latest data that we receive inside of this things board. So we can use this data, right, as our dashboard. So the problem in this project, right? What the heck? Okay, the problem as you see here, the problem to bridging the LoRaWAN gateway, right, to the cloud server, we cannot rely on these two because those are different. Those two are different, I would say, providers. So we need to hack a bit, right? So we need to create something like bridge, right, between LoRaWAN gateway and uh, this things board, right? So first of all, we need to understand how this things board upload the data, right? How the method, for example, if we use MQTT to upload data to things board, right? Things board, we need to understand how the process itself, right? For example, so we need to have this, oh, manage credential, right? So basically, how we obtain this one, right? So we need to define first the device, the credential when we create uh, the device here, right? And in things, but we need to define all of this value and how we define this one, right? So that's why we need to understand how we are going to do I would say uplink data to this device. We need to understand that one. If we understand very well, right, we can do the bridging itself, right? So basically, since I use these free versions, right, there is no such, uh, feature to bridging, automatically bridging uh, these things board to Lauren server. So the thing that if you want to have that kind of bridging, right, you can buy the professional versions of things board. That one have the feature to do the bridging between chip stock, right, the Laurent server that we have and the things board. But you know, since we are doing a low budget project, right, there is no such uh, budget, right? So just just bear with this situation. So what I did here, right? Here, so I create the bridge called chipsock things board bridge using Python. So basically, let's see what it did lah. So it only you see it on first. Uh, I will try to explain in the article if there is much time to there is enough time, right? So basically, what it did, right? First, the script will need to subscribe into the LoRaWAN server MQTT, right? And then after it subscribe, it will detect if there is any message come what is it to this topic, right? Topic name, and after that, it will uh, bridging, right, or distribute anything that comes into this topic. So after that, basically it's just parsing the data and publish it into the things board MQTT server. So yeah, if there is much time left, so I will try to draw some diagram to explain it better. So, however, yeah, this is the implementation. So let's go back to our things board. So let's run. So actually, I already create a service to run this Python file automatically. So we just need to uh, wait for the incoming data, right? So let's see side by side. We just want to wait our LoRaWAN to send the data, right? Oh, it seems that we just received. We just missed new transfer data. So let's see. Yeah. Okay. Seems that we have received new data. Incoming new data. Let's see if we have got the log. Seems that we 0704. Okay, let's wait till we receive a new incoming. So yeah, this is the Modbus query data. So we just need to wait, right? So it's sampling every 20 seconds. So let's go back to so here is the our credential. Let's remember this one so we can check it in the log. All right, it seems that we receive new incoming, right? So as you see here, as we can see here, username that I where is my credential? Yeah, username. I use this information as username, right? The client ID, and then client ID. Maybe it's a bit mixed. So this is the username that should be the client ID, and this one. I know it's a bit mixed, right? So I want to view this client ID here. So it's not showing the username, but so that's why I need to mix it with this value. So I need this client ID here. I put it as the username, and the username I switch it uh, into the client ID in device credential. So yeah. So so what else? I think uh, that's all from this demo for this project. Actually, the intention or the target of the project is fulfilled, right? The thing left that I need to create is the dashboard. I haven't gone through. Uh, so I haven't gone through the dashboard uh, maker, and so at least I at least the target of this project is is re yeah, we get the target of this project means that you can get the Modbus data and deliver it to the our cloud server. Okay. If you have any detailed questions, any uh, inquiry, or you are interested with this hardware, uh, Anything that you need to clarify with me, just ping me. Uh, we'll happy to answer your questions. So that's all, everyone. Thank you for watching the demonstration. Goodbye.